Hi everybody, let us see the Cartesian or rectangular coordinates. In this rectangular coordinates system, three coordinate axes are there. That axis x, y, z are mutually right angles to each other. Consider a point P of x, y, z in space at distance r from the origin. The vector r can be represented as r equal to capital Ax small x vector plus capital Ay small ay vector plus capital Az small az vectors. This small ax vector, ay vector, az vector are base vector or unit vector. Then capital vectors are component vectors. A unit vector in a given direction is vector in the direction divided by its magnitude. It's given by dsx equal to dy dz ax, dsy equal to dx dz ay, dsz equal to dx dy az. Those three vectors, the range of coordinate variables is minus infinity to plus infinity of x, minus infinity to plus infinity of y, minus infinity to plus infinity of z. Again, differential elements in Cartesian coordinates is increase each coordinate by a differential amount, then a new point q will be obtained having coordinates. Then differential vector length also, elementary vector length can be represented as dl. So the differential length given in the slide, dl equal to dx ax plus dy ay plus dz az. Q is a distance of point P given by the magnitude of the differential vector length. We took the magnitude for dl, so modulus of dl vector equal to root of dx square plus dy square plus dz square. This is the distance of magnitude. Hence the differential volume of the rectangular parallelepiped is given by a ds vector represented as dv. And this Cartesian coordinate system always include the differential surface area of the element and a unit vector normal to the surface ds. Next, we have to see cylindrical coordinate system. In circular cylindrical coordinate system is very convenient wherever we are dealing with problem having cylindrical symmetry. A point P in cylindrical coordinate is represented as rho pi z and is shown in the given figure of cylindrical coordinate system, where rho r is the radius of the cylinder passing through P or the radial distance from the z axis. Even pi is called a mutual angle is measured from the axis x axis in the xy plane. Z is the same as the Cartesian system. Even though the range of the variables are rho can have 0 to infinity to pi is 0 to 2 pi, z is minus infinity to plus infinity. A vector A in cylindrical coordinate can be written as A equal to A rho A pi A z. That cylindrical coordinate vector can have two adopted with magnitude of modulus A. This cylindrical coordinate properties are given the representation of A rho A pi A z according to their differential equation relations. These relations between the variables x, y, z of the Cartesian coordinate and the cylindrical system rho pi z. The cylindrical differential elements are dl equal to d rho a rho vector plus rho d pi a pi vector plus dz az vector. This differential normal area is given by ds equal to rho d pi dz a rho. It includes the following figure and cylindrical representation of formulas. Next, let us see spherical coordinate system over here. This spherical coordinate system is most appropriate when dealing with problems having a degree of spherical symmetry. A point P in spherical coordinate system is represented as r theta pi and is illustrated in the given figure of spherical polar coordinate system, where r is defined as the distance from the origin to point P, or the radius of a spherical centroid at the origin and passing through P. Pi is the angle between the z-axis, the position vector P, and theta is the angle of z-axis, the position vector P. Pi is x-axis, angle is position vector. Then the range of the variables are 0 to infinity to thetas or 0 to pi. Pi is 0 to 2 pi. A vector A in spherical coordinates may be written as capital A or A theta A pi. The relationship between the space variables of x, y, z, r theta pi and rho pi z according their representation can have to give the smart compensation vectors. Then will lead to differential spherical length. That differential elements are dl equal to dr ar vector plus r d theta a theta vector plus r sin theta d pi a pi vector. Those representation always can give a smooth and spherical coordinate differential volume according on the representation over here. Thank you.